Let's start with a shocking fact that most people still don't believe. Time travel is real. Not as science fiction. Not as fantasy. Not as maybe one day. It's already proven by physics. But here's the important detail. It's not the kind of time travel where you jump into a machine, press a button, and go back to ancient Egypt. The kind of time travel that physics proves is very specific. White heavy checkmark travel into the future. And it works like this. If you move extremely fast, or you stay near extremely strong gravity, time passes differently for you compared to people far away from that speed or gravity. So while you feel normal, the world outside you moves forward faster. When you come back, you are literally in the future. That's not an opinion. That's not a theory. That is a measured, tested, confirmed fact. And today, we're going to break it down like a real documentary. How science discovered it. Why it happens. Where we've already tested it. And how close humans are to doing it on a big scale. Most people grow up believing time is universal. Meaning, 1 second for me equals 1 second for you equals 1 second for everyone. It feels obvious because in daily life, time behaves normally. But physics says something far more strange. Time is flexible. Time can stretch. Time can slow down. Time can speed up. This idea became real science in 1905 when Albert Einstein introduced special relativity. Einstein's big message was, the speed of light is constant for everyone. Even if you move fast, even if you chase the light, you still measure it as the same speed. Now, if the speed of light never changes, then something else must change instead. And that something is time and space. This is where time dilation comes from. Time dilation means when you move faster, your time slows down relative to someone standing still. So your clock ticks slower. Not because your clock is broken, but because time itself is moving differently for you. And it's not a small effect. At low speeds, it's tiny. But near the speed of light, it becomes massive. Let's make this very easy with a real example. Imagine two people. Person A stays on Earth. Person B goes into a spaceship traveling extremely fast. Now here's the key. Inside the spaceship, person B feels normal. Their heart beats normal. They eat normal. They sleep normal. But from Earth's perspective, person B's time slows down. This is not a visual illusion. This is measurable reality. The closer you get to the speed of light, the slower time moves for you. If you could travel at 90% the speed of light, time slows noticeably. 99% the speed of light, time slows dramatically. 99.999% the speed of light, time almost stops compared to Earth. So if you spent 1 year on that ship, Earth might experience 10 years, or 100 years, or even thousands of years depending on speed. Meaning you return home and everyone is older, the world has changed, and history has moved forward. That is literally traveling into the future. And here's the most important thing. Einstein didn't just claim this. Scientists tested it. Again and again. And it passed. Now here's the second method, and it's even stranger. Einstein later introduced general relativity, which explains gravity in a completely new way. Instead of thinking of gravity as a force, Einstein said, gravity is the bending of spacetime. In simple words, massive objects like planets, stars, and black holes bend time and space around them. And when spacetime bends, time slows down near strong gravity. That means time moves slower, closer to Earth. Then in space, time moves slower, near the sun, then far away. Time moves extremely slow, near a black hole. So a person near a black hole could experience 1 hour for them, while years pass for someone far away. And again, this is not science fiction. This is part of real physics. And this effect is so real that we actually correct for it every day. Because without correcting for gravitational time dilation, GPS would not work properly. So in part 2, we will go deeper into something even more powerful. The strongest proof ever. Atomic clocks, GPS satellites, and real experiments that show time travel is already happening. Now that you understand the basic idea, speed and gravity can change the flow of time, the next question is obvious. Has anyone actually measured it? Yes. And the proof is one of the most beautiful things in modern science. To measure time dilation, scientists use something called an atomic clock. Atomic clocks are not like normal clocks. A normal clock can lose seconds or minutes. But an atomic clock is so accurate that it can measure time differences so small they are almost impossible to imagine. We're talking about billionths of a second. And even smaller. Atomic clocks use the natural vibration of atoms, like cesium, to keep time. And those vibrations are incredibly stable. Now, here's what scientists did. They took atomic clocks and placed them in different conditions. One clock stayed on the ground. Another clock went into an airplane and flew at high speed. When the plane returned and they compared the clocks, the clock that traveled was different. It showed a different amount of time had passed. Not because the clock was damaged, but because time itself changed for the moving clock. That means the clock in the plane experienced time slightly slower. So even though the difference was tiny, it was real. It was measurable. And it matched Einstein's equations perfectly. This was one of the clearest confirmations that time travel into the future is not fantasy. It is built into reality. Now let's talk about something even more mind-blowing. Your phone proves time travel every day. Yes, your phone. Because of GPS. Most people think GPS is just a map tool. But GPS is actually one of the most advanced physics systems on Earth. GPS satellites orbit high above Earth. And because they are in space, 1, they are moving fast. 2, they are also in weaker gravity compared to Earth's surface. Both of these change time. Here's the strange part. Speed effect. Because satellites move fast, their clocks should tick slightly slower. Gravity effect. Because they are farther from Earth, gravity is weaker, so their clocks tick faster. So satellites experience two competing time dilations. And when scientists calculate it, the final result is GPS satellite clocks run faster than clocks on Earth. If we didn't correct that, GPS would become inaccurate very quickly. In fact, without relativity corrections, GPS errors would grow by kilometers within a day. So engineers must constantly correct GPS time using Einstein's relativity. This is not theoretical. This is not scientists believe. This is a technology you use daily. So when someone says, time travel is impossible, you can calmly say, time travel is already built into your smartphone. Now let's bring it closer to human experience. You might ask, okay, clocks change, but what about real people? Yes. Astronauts have already time traveled into the future. Not by years. Not by decades. But by a tiny amount, still real. Astronauts on the International Space Station travel around Earth at about 28,000 kilometers per hour. And live in a different gravitational environment than people on the ground. So their time passes differently. When they return, they are technically a little bit younger than people who stayed on Earth. Again, it's a small difference. But the point is huge. A human body has already experienced time dilation. A human being has already moved into the future, even if it's only by milliseconds. That is the first step. It proves the principle works. Now you might be thinking, if time dilation is real, why don't I feel it? Great question. The answer is simple. Because the effect is tiny at normal speeds. When you drive a car, you are moving fast by human standards, but extremely slow by cosmic standards. Compared to the speed of light, your car is basically standing still. Even a jet plane is still incredibly slow compared to light. So the time dilation effect exists, but it's too small for your senses to notice. You need atomic clocks, satellites, or near light speed particles to detect it clearly. But the effect is always there. Even if you walk from one room to another, your time changes by a microscopic amount. So yes, time travel to the future is not a one-day concept. It is happening all the time. The only difference is, we haven't mastered it at large scale yet. So far, we proved something important. Time travel into the future is not science fiction. It's already measured, tested, and used in technology. But now we're ready for the most exciting part. What would happen if humans could travel near the speed of light? How far into the future could you go? 10 years? 100 years? 10,000 years? In part 3, we'll explore the most fascinating scenarios and the real physics behind them. Now let's move from proof to imagination, but still grounded in real physics. Because once you accept time dilation is real, the next question becomes: how far into the future could a human actually travel? To answer that, we need one key idea. Time dilation is not linear. It doesn't increase slowly like normal. It stays small at low speeds. But as you approach the speed of light, it becomes extreme. Let's use a simple scenario. A spaceship travels so fast that time slows down for the astronauts. Inside the ship, the crew experiences 1 year of travel. But on Earth, maybe 10 years pass. So when they return, they are 1 year older. Earth is 10 years older. That means they traveled 9 years into the future. And here's the wild part. This is not impossible in physics. It's only difficult in engineering. The universe allows it. Now push it further. If the ship travels even faster, 1 year on the ship could equal 50 years on Earth, 100 years on Earth, or more. Meaning you could leave Earth in your 30s and return to a world that has changed beyond recognition. New cities, new technology, new politics, maybe even a completely different civilization. You would be a living visitor from the past. There's a famous physics story that explains this perfectly. It's called the twin paradox. Imagine twins. Twin A stays on Earth. Twin B goes on a spaceship traveling near light speed. Twin B travels for some time and then comes back. According to relativity, Twin B will return younger than Twin A. That's not a trick. That's the math. And it's one of the most important thought experiments ever created because it forces you to accept time is not universal. Two people can live through different amounts of time even if they started together. Now, people often ask, wait, doesn't each twin see the other as moving? So shouldn't each one think the other is aging slower? That's where the paradox comes from. But physics resolves it. The traveling twin changes reference frames when turning around and coming back. That breaks the symmetry. Meaning, the traveling twin is the one who experiences less time. So the twin paradox is basically a time travel story written in the language of real physics. And the result is unavoidable. The faster you travel, the more you jump into the future. Now here's where we have to be honest. Time travel to the future is physically allowed. But doing it in a dramatic way, like jumping hundreds of years, is extremely difficult. The problem is not time. The problem is speed. To get near the speed of light, you need massive energy, incredible fuel efficiency, and a spacecraft that can survive. Because as speed increases, the energy required rises dramatically. The closer you get to the speed of light, the harder it becomes to go faster. In relativity, you can get close to the speed of light. But reaching exactly the speed of light would require infinite energy. So no object with mass, like a human or a spaceship, can reach light speed. But it can approach it. So the challenge is not a law of nature saying no. The challenge is, we don't yet have the technology to accelerate a human ship to those speeds. At least not safely. But the principle is still true. Now let's talk about the most extreme future time travel machine in the universe. A black hole. A black hole is gravity so strong that spacetime is bent to the extreme. And remember, strong gravity slows time. So if you were near a black hole, but not inside it, time could slow down massively for you. This means you could orbit near a black hole for a short period. And far away, years could pass. Maybe decades. Maybe centuries. If you came back, you would return to a distant future. Now, there's a huge warning here. Getting near a black hole is incredibly dangerous. Tidal forces could rip you apart. Radiation could kill you. And you may never escape if you get too close. But again, physics allows the concept. This is why scientists say time travel to the future is not a fantasy idea. It's already built into the structure of the universe. Speed and gravity are literally time machines. So now you understand the reality. Time travel to the future is proven. It happens through speed and gravity. The universe allows huge jumps forward. The only limitation is technology. Now the big question that most people are waiting for. What about traveling to the past? Can quantum physics help? Do wormholes exist? Are paradoxes solvable? In part 4, we'll cover the most mysterious part and the most misunderstood. So far, everything we discussed is time travel into the future. And the reason it works is simple. Relativity doesn't break logic. It just changes how time flows. But traveling into the past is a different beast entirely. Because past time travel doesn't just challenge engineering. It challenges reality itself. The moment you allow someone to go to the past, you open the door to contradictions. For example, you go back and stop your parents from meeting. You go back and prevent your own birth. You go back and destroy the time machine before you used it. These are not just movie plots. They are logical paradoxes. And physics is built on consistency. So the big question becomes, if past time travel is possible, how does the universe prevent contradictions? This is where things get really interesting. Because quantum physics enters the conversation, but not in the way people think. If you ask physicists what the most serious theoretical possibility for time travel to the past is, the answer is usually wormholes. A wormhole is like a tunnel through spacetime. Instead of traveling across space normally, you take a shortcut. Think of spacetime like a sheet of paper. Normally, to go from one point to another, you move across the surface. But if you fold the paper and poke a hole through it, you connect two distant points instantly. That's the wormhole idea. Now, here's where time travel comes in. If one end of a wormhole experiences time dilation, for example, one end is moved at near light speed and brought back, then the two ends could become out of sync in time. Meaning, entering one end could send you to a different time at the other end. This is one of the few serious models where past travel appears mathematically possible. But there is a huge problem. Wormholes, if they exist, are likely microscopic and unstable. To keep a wormhole open, theory suggests you need something called negative energy, or exotic matter. And while quantum physics has tiny effects that resemble negative energy in very special situations, we do not know how to create it in the amounts needed to stabilize a wormhole. So wormholes are a mathematical possibility, not a proven reality. Now let's address one of the biggest misunderstandings online. Many people claim quantum physics proves time travel. They say things like, entanglement sends messages faster than light. Particles go backward in time. Quantum mechanics breaks causality. But here is the truth. Quantum physics is strange. But it does not automatically mean time travel. Quantum entanglement. Entanglement creates strong correlations between particles. If you measure one, you instantly know something about the other. But it does not allow you to send a message into the past. You can't use it like a communication device. The universe doesn't allow that. So entanglement is not a time machine. Quantum particles and backward time. In some physics equations, particles can be described in a way that looks like they move backward in time. But that is usually a mathematical interpretation, not a real go back and change history effect. Quantum mechanics and causality. Quantum physics can be probabilistic. But it still respects cause and effect in the real world. So quantum physics doesn't give us a magic door to yesterday. What it does give us is something else. A way to think about paradoxes. So what's the final answer? Can we travel to the past? The honest scientific answer is, we don't know. But we have zero experimental proof. And many physicists believe the universe may block it completely. There are two major ideas scientists discuss. 1. Novikov's self-consistency principle. This idea says, if time travel to the past exists, you cannot change history. You can only do things that already happened. So paradoxes are avoided automatically. For example, you go back in time to stop an accident. But your actions actually cause it. So history stays consistent. 2. Many worlds interpretation. This idea says, if you go to the past and change something, you don't change your original timeline. You create a new branch, a parallel reality. So there is no paradox. But again, this is theoretical. We don't have proof. Now here's the most important point for your viewers. Time travel to the future is real and proven. Time travel to the past is not proven and may be impossible. And if it is possible, it likely won't look like Hollywood. No changing history. No rewriting your life. No undo button. The universe may be far stricter than fiction. Final ending, strong closing message. So let's end with the real truth. If you want to travel through time, you don't need a fantasy machine. You need extreme speed or extreme gravity. And physics confirms it. The future is not locked. The future is reachable. But the past? The past may be protected forever.
Subscribe Info Beyond Borders now for more mind-blowing knowledge.